channel. This is Pendomatics, your complete online school of mathematics. And what we do here is we break down mathematics, taking it topic by topic, and making it easy for you to understand, to follow, and to become better at maths ultimately. Alright, welcome again. I'm Pendulum. I'm your tutor on this channel. And if you're new, you're very welcome. Please consider subscribing to the channel so that you become part of us. And you turn on our notifications. Ring that notification bell so that you don't miss any of our new videos or new content. We upload a lot, 2 to 3 videos a week, and each one has something new to teach you. Okay, so welcome. We are still looking at variation, which we said is the relationship between two or more quantities. And today we are in the last subtopic on that variation, which is partial variation. So this is where we have 2 videos. This is the first video on partial variation. Alright, so as we go into it now, don't forget, like the video, just drop a thumbs up on the video. Do it right now. It helps with the algorithm so that more people can find the video, watch, and learn. Then drop your thoughts in the comments. If you have questions, observations, whatever, put it down in the comments so I can read from you and engage with you. And then very importantly, share this video far and wide. Copy the link, put on WhatsApp, put on Facebook, share to your friends, family, neighbors, enemies, everybody. All right, let's help others understand partial variation. All right, so let's go. We said partial variation is a type of variation that consists of the sum of 2 parts and is made up of 2 constants. So all the other type of variations we've looked at, from direct, inverse, joint, has just 1 constant. All right, direct has 1 constant and 2 quantities of variables. Inverse has 1 constant and 2 quantities of variables. Joint has 1 constant and 3 quantities of variables. But in case of partial, we have 2 constants. Alright, so partial has 2 constants. It's a type of relationship that is a sum of 2 parts. So just like we see here, here, and here, a partial variation has 2 parts, 2 parts, 2 parts, and it's a sum of the 2 parts. Alright, so these are some of the forms that partial variation can take. Some of the most popular forms that we see in questions that partial variation can take. First of all, we have that y is equal to a plus bx. Now, partial variation mostly has the types we'll be looking at this level have 2 constants and 2 variables or 2 quantities. And the quantities we are comparing are x and y and x. All right. So this first form, y is equals to a plus bx. A and b are constants. A and b are constants. A and b are constants. All right. So this tells us that y is partly constant. You can see that only a is here. Nothing is attached to it. So in this first, remember, this is the sum of 2 parts. This is 1 part. This is another part. In this first part, y is constant, meaning the value of whatever is here will not change throughout your solving, throughout your equation, or throughout your solution. The value of whatever is here is constant. All right, so y is partly constant and then partly varies directly at x. On this other part, it varies directly at x. You know how we have direct variation where we will say, okay, y is equals to bx if b is a constant. Although we're using k for the videos we made, but it's a constant, it can have any value. So if we say y is equals to bx where b is a constant. That's the second part. So y is equals to, if you ignore this, just have y is equals to bx, which is the direct variation. So that's why we say for this first form or first type, y is partly constant. This place is constant. Nothing will affect this. It will just really, value will remain like that. Plus partly varies directly as x. Remember I told you for direct variation, they better tell you partly varies directly or just partly varies as, or it is proportional to. If they don't specify any other kind of variation, you assume it to be direct. So this one, y is partly constant and partly varies directly as x. That's the interpretation of this. Then this other form, you have that y is equals to ax plus bx squared. Now a is no more constant because a has a variable attached to it. The value of a here now will be changing throughout the solution depending on the value of this variable attached. So for this case, we say y partly varies directly at x. This first part now means that y partly varies directly at x. It's like writing y is equals to ax. Remember that b and a are constants, like we've said. So only this first part now is like saying y varies directly as x. Although here we say it's partly because there are 2 parts. So this is 1 part, this is another part. So y varies partly as x, and also partly as x squared. Y varies partly directly as x and partly directly as x squared. So both cases here are direct variations. Even merely looking at it, you know that it's direct. It's not inverse. If it's inverse, there will be division. So both of them are direct, but this one is partly direct as x and partly direct as x squared. Okay, so that's the interpretation of this. The difference between these two, this is a constant, it doesn't change. This one will change. Then the last form here is this. Now again, y varies partly constant as a in this first part. Y varies partly constant as a. All right, just like here. But here now we can see that this is inverse variation on this second part. So this interpretation here is that y varies partly constant as a and partly inversely as x. So y is partly constant and partly varies inversely as x. That's the interpretation here. It's constant here, but on this side is inverse. You can see the division. All right, so these are the most popular forms that it takes. And if you remember these forms, whenever you see any question, you relate it to either either 1, 2, or 3, and then know what to do. All right, so let's look at this example. We are told that a number p varies directly as q and partly inversely as q squared. Varies directly as q. P is equals to, now let's use a and b as our constants. We've already started using it. So if it varies directly as q, aq, right? P is equals to aq. Varies directly. It does not vary constant directly. So it's this second form we are using. And then partly inversely as q squared. So this is what your variation should be. The first one varies directly, partly directly, of course, as q. So these are constants and then q. This first part is direct variation. Then the second part is inverse variation. So that's why we have b, the second constant, all over q squared. So a and b are our constant here. All right. And now we are given two. Now the another difference to note here is that in partial variation, because we have two constants, we are going to have two sets of values we are going to need to find our constants. For direct variation, inverse variation, joint variation, they only give us one set of values and we substitute it to find our constant. But in this case, we have two constants. So we are going to need two sets of values. We take them one after the other. So for the first set, we have that, okay, first, we are told that P is 11 when Q is what? 2. The first set of values we are given. So we substitute this into this to get an equation. We also substitute these two into this. So let this be our original equation. We also substitute these two into this to get another equation, and then we sum them simultaneously. Alright, so this will always lead you to simultaneous equation. And if we substitute this, therefore P is 11, A times 2, that's 2A, plus B all over 2 squared. Okay, 11 is equals to 2A plus B over 4. Now, it will make sense for me to remove this fraction, all right, so that we are not working with fractions. So to remove this fraction, I will multiply through by 4. I will multiply this, and this by 4 to remove the fraction. So multiply through, let me just write it out. I'll multiply through, by 4. And 11 times 4 is 44. 2A times 4 is 8A. And if I multiply this by 4, 4 will cancel 4 plus B. So let me call this equation 1. Alright, I'll call this equation 1. Then second, we are also told that P is 25.16 when Q is 5. We're also given this instruction or these values. So we also substitute them into this original equation. So therefore, 25.16, which is P, is equals to AQ, and Q is 5. So 5A plus B over 5 squared, that's our Q. 25.16 is equals to 5A plus B over 5 squared is 25. Now, just like this, we want to remove this denominator 25. So we multiply through again by 25. We multiply through by 25. Multiply through by 25. So 25.16 times 25. 25.16 times 25 gives you 629, and then 5 times 25 should be 125a, plus if you multiply this by 25, 25 will come to 25b. I'll call this equation 2. Alright, so now we have equation 1, equation 2. This will lead us to a simultaneous equation. So if at this point you do not know how to solve simultaneous equation, I would suggest you pause this video, check this channel. We've covered simultaneous equation in depth. We covered different methods of solving simultaneous equation. You have your factorization method, completing the square method, quadratic formula method. We even covered graphical method. Alright, so if you don't know how to solve simultaneous equation, go take maybe 30 minutes to 1 hour to watch the videos on simultaneous equation so that you understand how to solve it before you come back and continue here, because if not, you may not understand what we'll be doing next. So let me bring this one here so that our two equations will be in the same place. So we have that 44 is equal to 8a plus b. This is equation 1. Then to solve this, I'm just going to do equation 2 minus equation 1. I'm just going to subtract equation 1 from equation 2. Why am I subtracting this? I want to eliminate b. I'm using elimination method. So I want to eliminate b. Now, because the coefficients of b are the same, I can use minus to get rid of b here. Alright, so 629 minus 44 minus 44 will give me 585. 125 minus 8 will give me 117a. b minus b is 0, so b is gone. Alright, so now to find a, I will divide here by 117. I'll divide here by 117. 117 can cancel 117. And if you divide this part, a is equal to 5. If you divide this, you get 5. So now I found the value of a. Alright, now to find b, I will substitute this a equals to 5 into equation 1. So let me substitute it into this. Therefore, we have that 44 is equal to 8 times 5. A is 5. Then plus b. Now, I'm looking for b. That's why I substituted the value of a here, so that we can find b. Alright, so I'll bring this one here, so that only b will be on its own. So 44 minus 8 times 5 is 40 is equal to b. And then 44 minus 40, b is equal to 4. Alright, so we found that a is 5 and b is 4. Therefore, if we put this into this, our original equation will be, therefore, our original equation p is equal to, a is now, I found it to be 5. So 5q plus b is 4. This is the original equation, please. P is equals to, a is 5, so 5q plus b is 4 all over q squared. Alright, so now this is our let's say our updated original equation when we found the value of a and b. All right, so if you are asked now to find the relationship between p and q, this is it. Remember, if you've been following these videos when we started from direct, inverse, joint variation, you will always know that the first thing you do is to get your equation like this, and then you put in the first set of values you are given to find your constant. And then you substitute your constant, the value of your constant, into the equation you got to get the relationship between the quantities, right? So that's exactly the same thing we've done here. Only that this took a longer process because it has two constants. But nevertheless, we'll find the value of our constant a as 5, constant b as 4. So we put it back into our original equation to get this. So this is the equation connecting p and q, or the relationship between p and q. Alright, so we found it here. Now, this is not where we are stopping. No, they say we should find the value of p when q is 7. So we are asked to find P. We don't know P, but we are told that Q is 7. So, as always, we are going to use this relationship. P is equal to this. So, we are told that Q is 7. 5 times 7 plus 4 over 7 square. P is equal to 5 times 7 is 35 plus 4 over 49. Alright, so there are many ways to solve this. But you know what I will do here? I will just use the simplest way. I don't want us to start doing LCM and all of that. So I'll just divide this. 4 divided by 49 will give me 0.082. And then P will be equal to, if you add these two, you have 35.082. So this is my value of P. Alright, 35.082. And it's all well and good that I get my P as a decimal, because in the question they gave us P here also as a decimal. So I can leave it like this. If I start doing LCM, I'm going to get my answer as a fraction. So this is a very simple way to do it. We have that P is 35.082 when Q is 7. Alright, so you can see that basically it's the same process. Only that in this case now, we'll need simultaneous equation to be able to find our constants. Alright, so if you understood this and you found it helpful, drop a like on the video. Drop a like now so that you don't forget. Just drop a thumbs up. And then if you have questions, put it down in the comments while I put your assignment on the board. Alright, so this is your assignment here. Y is partly constant and partly varies inversely as the square of x. Partly constant. So y will be equal to just a constant a plus then inversely b over x squared. That's the original equation. Y is equal to a plus b over x squared. Then you have to find the relationship between x and y. If x is 1 when y is 11 and x is 2 when y is 5. So you use these two values to create two equations, solve it simultaneously, get the value of your constants a and b, or whatever you decide to use as a constant. It must not be a and b. So I can decide to use k and l as my constant, or m and n as my constant. Okay, find the value of y when x is 4 and the value of x when y is 1. So it's something you should be able to do. If you follow what we did here, you should be able to do this. So try it and put your answer down in the comments. Maybe snap a solution, put it in the comments, or send it to me on WhatsApp, send it to me on Telegram, wherever you are more comfortable with. I will go through it and give you feedback. Okay. So thank you for being here. Remember, like this video, drop your thoughts in the comments. Very important. But most of all, share this video far and wide. Share it to friends, and your audience, and anyone you can get it to. Put it on your WhatsApp status so that other people will come and learn. This partial variation, many students struggle with it. Many students don't even understand it. In many schools, they don't even teach it. They just use direct, inverse, maybe even joints, and then they skip this because not everybody understands it. But you can see that it's not difficult. So help somebody out by sharing this. Okay. I'll see you in the next video. Keep trying, keep learning. Remember, subscribe to the channel. Don't forget that. Just hit that subscribe button and hit the notification buttons so that you don't miss any of our videos. Okay. Thank you so much. Don't give up. Math is not difficult. I'll see you in the next video. Bye.